So it says a systems of equations is an equation or group, aka system, of equations that we deal with all together at once. The solution, or sometimes plural, sometimes there's more than one solution, to the system are found at the intersection points of the graphs. And then it says systems can be made of lines or lines with other non-linear functions like a parabola, a quadratic, or a cubic, or a quintic, or sometimes they're just all non-linear. Systems can have many functions included, but they need as many equations as you have variables. So I'll tell you what I mean by that in just a moment. So copy in those blanks. Could you guys solve this equation?
Yes.
No.
Yes.
Yeah.
Yeah, what would we do?
We would
Add
Add 4 over, divide by 2.
X equals 1.
Yeah, so how many variables are in this equation? A variable is a letter that represents
One.
One variable, there's x, right? So we could solve that. There's one equation, there's one variable, okay? But what if I gave you this equation? Could we solve this equation? Could we figure out what x is?
Yes.
No. Because it could be any combination.
No, you can't solve for x if there's a y in the way, and we don't know what y is or what x is. It could be an infinite number of answers. So what we do is we combine it with another equation that's similar, that also has an x and a y in it. And in Algebra 1, you actually learn how to solve a system of equations. You remember something looking like this with the bracket? So what we typically do is you can eliminate them, you can substitute, so you can find out what x is and then substitute it into the other equation and find out what y is. But how many variables do we have? Two. How many equations does it take to solve that? Two. Now, I don't know if you did this in Algebra 1 or not, but sometimes you get something that looks like this. How many equations is it going to take to solve this? Yeah, you have to have 3 of them so that you can use one of them to find x, and then you can substitute that into the others to find y and z. Now, in Algebra 1, you kind of learn how to do that algebraically. We're going to skip that, and we're going to kind of learn how to do that on your calculator and graphically for this class, okay? So what we're trying to find out is what equations or what variables of x, y, z, what values work for those equations. So what's happening is, so let's say I have a line and I have a parabola. When are those equal? So it's like if I had 2 equations. So if I had an equation of a line, so y equals 2x plus 3, and I have some quadratic y equals x squared plus 2x minus 4. So it's a system of a linear equation and a nonlinear equation. This is a quadratic. So that's kind of a pain in the butt to solve. But if we graph it, we can use the graphs to find the x and y values that work for both equations. So what did the little definition tell us? When are these two things equal?
When they intersect.
When they intersect. So how many times do they intersect?
Twice.
Yeah, one right here and one right here. So that is when the x and y values are the same. So those x and y values are the x and y values that would work in these equations. It says, given a line and a parabola, how many intersections are possible? What's one scenario? I just showed you one of them. Two. So if you draw kind of a line maybe that's going up like this, there would be 2 solutions. There's 2 solutions. In other words, there's 2 points of x and y values that are always going to work. If you find those points, when you plug them into the equations, they're going to work. Okay. What's another possibility? 1. What would have to happen for one solution?
Go right down the middle.
Yeah, it could go down the middle, but basically some kind of vertical line would do it, right? So that would be 1 solution. And there's one more scenario.
3 or more.
Could a line cross a parabola 3 times?
I don't think so.
Oh, another one. Let me. This is kind of. It happens sometimes, but sometimes a line will kind of like Yeah, it'll just hit it and bounce off. So that's another. You'll see that later today. So that's also a one way to have one solution. There's one other possibility. It's not 3.
No solution.
No solutions. In other words, there are no x and y values that make those equations work. So graphically, what would that look like?
Just like
Yeah, it could be like under it or out to the side of it. But basically, that line is never going to intersect that parabola. Nope, it never would, right? Because this is expanding out much more rapidly than this one. So if they keep their same rate, then they would never intersect. Now you have to be careful though, because sometimes I'll give, or you'll see something that looks like this, and so you graph it on your calculator, because we're going to use our calculators again, and this is in your window. What's that going to look like? It looks like one solution, but if you expand your window out, what's eventually going to happen here?
it's gonna intersect.
They're going to intersect each other up here. So this is another practice where you'll want to make sure your window is good. If it's a diagonal line and a parabola, they are going to end up intersecting again. Okay, so keep that in mind. All right, so let's take a look at our first example here. It's on the bottom right. So let's go ahead and graph it. So go into your y equals, your y editor. So on your calculator, y equals. We actually did a systems of equations last class. Do you remember last class we had the horizontal line? We tried to figure out where that polynomial intersected it to find the volume of that box.
Yeah.
So we're going to do kind of the same thing. So y1, let's put our first equation. So 0.5x plus 5. And then y2, our second equation, we're going to put this quadratic equation. So 2x squared minus 5x minus 2. So we have one line, y equals mx plus b, and one quadratic with our ax squared plus bx plus c. So let's all start out at zoom 6. Standard 10 by 10 graph. So there's our line, there's our parabola. So is our window fine here? Yeah, it's actually, it's perfect. So how many solutions do we have to answer the question?
2.
There's 2 solutions. And it says go ahead and sketch the graph onto your page, so just so you have kind of a copy of the notes. So go ahead and just kind of copy what you see. Doesn't have to be anything special. So we have a parabola, and we can see that there are 2 intersection points. So we know that there's going to be 2 solutions. So just copy it over what you see. So let's actually, it doesn't ask us to, but let's go ahead and find those solutions. So what did we do last class on that very last problem, you remember?
Second trace.
Second trace.
Intersect.
And we're trying to figure out when do the 2 graphs intersect. In other words, algebraically, when are they equal to each other? When they're intersecting, that means they have the same x and y value. So hit 5. Second trace 5 for intersect. Now, this is where there's 2 different intersections, so you have to tell your calculator where to look. Which one do you want? So, see where it's saying first curve? So just move the cursor. Let's do this intersection on the left side first. So move the cursor kind of over to the left side where it looks like they're crossing each other on the left, and then hit enter. And then you can see the little cursor pops down to the parabola now. So once again, just kind of move it right at that intersection.
Wait, so where do you get the first one? What's the first curve?
Second trace 5, and it says first curve.
Yeah, but like,
And then move the cursor to the intersection.
Like just on the other.
Yep, just real close to it. You're basically saying, hey, I have a line here and I have a parabola here. I want you to look at this spot for both of them to tell me where they intersect. So then hit, bless you, hit guess, and it should already be there if you move the first 2 cursors close to that area. If you're guessing really close to where it's at, hit enter, and that is the solution point. So let's write that down. So let's round it to the nearest. So negative 0.9 for, let's go 4.68. 4 decimal places.
I want you to do that one
So
better.
10,000th points. And then comma 4.5266 is good.
You want them to go to
You don't necessarily have to go that far, but I'm going to show you why I'm going that far here in just a second. But real quick, let's go ahead and find the other answer now. So we do it one more time. Do second trace intersect is 5. But now we need to move our cursors over to the other intersection. So arrow over to the right and get it close and hit enter. And you can see it pops over to the parabola. Just kind of also get in the vicinity there, right close to that intersection on the right side. Hit enter again.
What's the second group? Do you want to go above or below?
Nope, we're not doing above or below. You're just putting the cursors on the intersection. And then that right there is your answer. So 3.6968, comma 6.8484. So you're just telling the calculator where to look for the intersection is all you're doing. It's not like we're finding an x-intercept or any of those zeros or anything, or a min or max where you could go left, right, middle. This is just get close to the intersection and hit enter. Okay, so now I'm going to show you what this means. So clear out of your graph. Just go to your normal old calculator screen. So on the test, these are your answers. You'd circle these and you'd be done. Okay, so was that hard? No, not hard. But let me show you what we just found. Every point, remember, is an x value and a y value.
So you plug it in.
So let's take this top equation right here, and let's plug in this x value for x. So let's type in 0.5, and now let's plug in the x value of negative 0.9468 plus 5. So I'm just typing in that top equation, the right side of it, the x side of it, and I plug in the x value. I plugged in this x value right here. Now when I hit enter, what do you think is going to happen?
It's gonna be the one.
It's going to be the y value, 4.5266. But there's another x value that works, is basically what we're just finding. There's 2 different x values that work. So now let's take this bottom x value and also plug it into the top equation. So if I do 0.5 times, so I'm doing the top equation, 0.5 times, and now I'm going to type in this x value, so 3.6968 plus 5. We found out that that's also an x value that works for this equation. It works for both equations. That's why they intersected. And you hit enter, and you get 6.8484. Now, what do you think would happen if I plugged both of those x values into this quadratic? They'd work again. They're both points. They're both solutions to both equations, is what we just found out.
So for the one with 2 x's, you have to do both of them.
What do you mean?
You have to do 2 different ones.
Yep, you'd plug in x. So if I'll just do one of them real quick. So if I do 2 times, I'll do this one on top. So I put it in parentheses, negative 0.9468, and then squared, minus 5 times, and then I plug in my x again, negative 0.9468 minus 2. So all I did is I typed in the quadratic, but I plugged in this x value. So when I hit enter, I should get 4.5266. And you can see how close it is.
Mm-hmm.
But we rounded our answer, so it'll be real close. Obviously, if you typed in the whole big long decimal that our graph gave us, it would work better, but you can see that it's real darn close. All right, last thing for today, I want you to do both of them on the back side now. So up at the top, that's just a review of the steps we just did, so if you forget, they're there. But you're just doing the exact same thing. So you have 2 systems of equations. I want you to find all solutions. So we have, once again, a parabola x squared plus 5x minus 10. And in the second line, we have a line of 2x plus 18. I like to start at zoom 6 always, graph zoom 6. Now you need both intersections on the graph. So what do I need to do to my window?
Up.
Up to, change my window to maybe like a y maximum of, let me try like 30.
We were supposed to actually find these, weren't we? We weren't just supposed to put like how many solutions.
You had to find the solutions. So as long, I don't need the vertex of the parabola. Do I care about the vertex of the parabola in this case? No, so you zoom your window to what you're trying to find. So I wanted to find those two intersections, and they're both on my screen. So second trace intersect is number 5. Now sometimes you can't see your cursor, but it's telling you where the x value that it's at. So right now it's at negative 8.5 right here, so it's like down here on the parabola probably. So if I move over, obviously this intersection is like negative 7 or 8-ish. So I need to move my cursor to the left until I get there. And there it is. So get it in the close vicinity, hit enter, hit enter, hit enter, and the answer is negative 7.4. Do you guys get negative 7.4?
Yes.
That's a weird 7. Negative 7.
I was really close.
There's on. If you typed it in wrong, it would have been. But that is the only answer. Negative 7.4. Well, correct answer for that point. And then you have to do it one more time. So second trace, intersect, and move your cursor all the way over to the other side. Sometimes it goes kind of slow. Get it close. Hit enter, enter, enter. You'll kind of find out that once it gets close, you can just hit enter, enter, enter. And the other answer would be 426.
Yeah.
That's what I ask of you. What's something that you could do to get an advanced on the test?
Put it in the
Plug them in.
equation, plug it in. So
Yeah, you
that
could
works.
plug each of these x values in for x. And if you do that, if you plug in negative 7 into this top equation, you should get an output of 4. And if you plug in 4 into either equation for x, you should get an output of 26. It's kind of another way to check your answer as well. It guarantees you're right. And then the last one was super weird. It's really shallow. It's kind of hard to see what's happening. But if you, let's graph these. X squared plus 4x minus 2. And 6x minus 3. I'm going to go back to zoom 6. Okay, now what kind of happened is there's something, they're really close to each other, right?
Mm-hmm.
You guys see that? Mm-hmm. So if I'm going to change my window so I don't have as much on the left side. So window, I'm going to change the x-min to like negative 2, see what that does. We kind of spread it out a little bit, it might look a little bit better. There, did you guys see what happened at the top there? So if I move my window up, so the y max is like 20. See the parabola? And then the line comes, it touches it, and you see it bounce off. Were you guys able to find a window that showed that?
I just said,
And you could even shave some more off of the x side, and that'll spread out the screen, so hopefully you can see that. So if I change my y or my x maximum to maybe like 5, really kind of zoom into that area. There it is. That's a good one right there. So if you do second trace, the intersect is 5, and it's already right there. Just hit enter, enter, enter. And if you get an answer, that means there is an intersection. If it says error, they might just come really close to each other, but they never quite intersect, right, Cole? So what is it probably safe to say my answer is here?
1, 3.
Yeah, did you? So 0.99999, you can just say that's 1. And 2.99999 would be 3. And that is the only answer because the line bounces off the parabola. It hits it, and then keeps going. Any questions on systems of equations?